So now we need to find a way to record audio, or in this case stream the audio, from Mac, Windows and Linux. I've done nothing so far, so this is going to be like an R&D and seeing how we discover how to find what we need. If we can't find what we need, we'll just make the code ourselves. But with it being fairly simple, in a sense, it should be a very well-defined thing. All we need to do is find some code that will allow us to stream audio from any connected microphone on a computer. Even the default microphone's fine. That's how the Ulian loudness meter works. You just have a default microphone to start with. So we'll go with that. So what do we know about our project? Well, our project is obviously using Avalonia, but behind the scenes that uses .NET Core for the code that's going to be involved in getting the audio. So what we want is a .NET Core solution. So we'll type in .NET Core, and then we want something like audio capture, audio stream, audio recording. Just start with the basic Google first. I haven't done any audio capture stuff for many years, so anything I already know will be well out of date on this. So this is how we'll start. We'll pretty much look for a bunch of articles, look for the dates that they're fairly new, probably look for NuGet packages, and this is going to end up in very likely downloading a bunch of NuGet packages and experimenting with them. So if I find a solution as well, I don't necessarily always jump straight into that solution. I'll do a little bit of searching first and see if the same solutions come up multiple times, instead of wasting time trying to set up projects. Some might look really simple, some might be really complicated to set up. So it's good to just start with a bit of research first. So the first thing we find, top result, which isn't always the best, is opentk.net. It uses audio capture classes to capture microphone data across different iOS platforms. So that won't work if it's only Mac. So we can copy this, search for this as well. Let's just take a quick look at the website. It's had 3.4 million downloads, so should be pretty stable. Open toolkit, low-level C# binding, blah blah blah, major platforms. So where the platform supports, it runs on all major platforms. The platform list would definitely be helpful. That's like literally the first thing I want to know. Search for the word Mac. There we go. Facts and questions. Okay, it runs on Windows, Linux, Mac. So that one's a possible candidate. There's no buy button, so that's free. Keep going. Let's have a look at a few other options. Got N audio. You can see this cool little bar, which is actually pretty much what we're going to be replicating as well. So that's a good little example that we could use to figure out straight away. That might be worth just bookmarking, because this is a percentage bar on audio level, and they've done it through effectively this math here. So that's going to be a very useful thing for us to keep. So even if we don't use that, that's already a nice bit of code there for calculating volume level. Left and right channels. See, this one's got some nice documentation straight away. N audio. And again, I prefer currently this homepage than this homepage, for example. This looks a bit old schooly. So not necessarily the right way to pick a project, but it's certainly the way I will start that. If I like the look of something, I'll have a go of it. Playback audio using a variety of APIs, wave out, direct, iOS, blah, blah, blah. Bunch of open issues, which we may not find or come a problem with. Fairly active discussions going on. So it's still an actively developed code base, I'd say. The last release was last year, so again, seems pretty solid and usable. It's used by 10,000 people. It's got 65 people contributing to the repo, so it's going to get maintained, I'd say, fairly well. And if we jump on OpenTK's code base, we can see this is actually used by less people, but maintained by more. So to be honest, even though it looks like it would be more, they're probably about even on how many people use them. The key on this is, does it use .NET Core? You'd certainly think so by now. And I think, wasn't the example we used .NET 6? Yep, so this should be fine. Yep, so both of them are options. Let's have a look at a few more. And I think by the looks of it, there's no need to make our own code for sure. We have clearly well-defined cross-platform audio capture code bases. There's no point wasting our time making our own code for this. Nope, that's more just of an article. Okay, so there's not that much on there. So to be honest, we've probably found the top two. So let's type in open TK versus N audio, and they don't instantly pop up as a Google completion, like an auto completion, so they've probably not compared much, and they're not talked about much either by the looks of this. So let's just try OpenTK versus. So the next one it recommends is SharpGL, and this is more for game development. So it sounds like, because also OpenTK I think mentioned on their website something about it's not game development related or something. I think I read up here. Sure, read something when I glanced over. Yeah, it's not a game engine, nor does it try to be one. So to me, it's almost like this is hinting at some kind of game developer background and it's been converted to be used for audio. That's just my initial guess on what I've seen. And again, look at OpenTK. Alternatives are graphic related programs. So I'm guessing, and just from that quick and possibly completely incorrect analysis, that OpenTK is more game related that's been converted back to this library helping with audio, which means it's probably going to be a lot more cumbersome than a dedicated audio code. On top of that, this N audio has this nice sample we're going to use as well, if it works. So I'm just going to head and close OpenTK for now. And let's take a look at using N audio. So even without doing anything, normally, if there's a NuGet package, all we need to do is add the NuGet package. In this case, it's also cross-platform, I believe. We did read that. And unfortunately, it doesn't. It only supports Windows, so that's a real downer for that one. So we could use it for Windows, but then we'd have to use it for a different solution for Mac, which is also an option. We could use this for Windows and another for Mac. So I think then we're going to have to try OpenTK to start with. I'm just not sold on this game development side of things. No, it's definitely graphics related. So just because there's an API for reading audio, that's not a solution. So we don't currently have a solution then. This is still open source.NET audio library, but obviously open source to just access Windows related stuff. Let's download the demo because it may have been updated. Improved targeted to make it easy to use on non-Windows platforms. So maybe this works on non-Windows platforms now, maybe not. Yep, and this is complaining that the Universal Windows Platform SDK is supported only under Windows. So this is definitely looking like a Windows-only project. So I still like an audio on there, but let's look again then. So go back to Google, we're not done yet. Cross-platform audio capture. C# wrapper for SoundLab IO, cross-platform audio IO. Go straight into example. Microphone, and let's see what this does. Microphone and run, and hopefully this doesn't screw up the recording, because obviously we're using a microphone right now to record this video, so we'll see if this interferes with that as well, or for one, if it even runs to start with. libsoundOS can't be, so when you've first downloaded files you need to approve them in Mac, so this will still happen if we release the software. We'd have to, like, people on Mac would know this. Basically, you have to approve what you've downloaded is valid. So we'll just open settings, privacy and security, and if we scroll down, it should now be in here somewhere. There we go. So it's already flagged that it was blocked. So allow anyway, and that should now allow this program we've literally just run to run past that point. And let's see if this now works. I think we'll get a dialog down here. It's going to be obviously command line. So now it's got another one. Oh, you sure you want to open? Yep, we do. And now we've got another problem. Incompatible device. The output's been set up the same. Open the output stream. So it's the output stream that fails, saying that we can't output. So I'm not sure where the sample's trying to output to here. So it creates an output stream, creates the format, adds that, opens, and then it's trying to read and write back and forward through events. So in fact, we don't actually need the output whatsoever. So for now, let's get rid of the output. This is obviously a very messy bit of code for now, but this is how we start. You don't want to clean up code when you're just literally messing around and debugging to see if you can get things working, because it's a waste of time. If it's not going to work, then there's no point going any further. So this is now running. So I presume, do we get... There we go. Rider would like to access your headphone. So that's okay. We've now got the headphone, and now another problem. So what's the problem now? Invalid value. So this is now... Is that it? That's all the info we get. So begin read, frame count, return value, sound IO error invalid. So the only thing we did is we removed the output device. I'm wondering whether we broke that, because it's like the buffer runs out. So just undo all changes, and let's just see where this ring buffer is used, because it's obviously working. I think we just broke the demo code by removing the output. So I'll bet you any money this output, ring buffer, create a ring buffer, right point, and we probably don't need any of this. Like I say, we'll rewrite this code almost for our needs. We just generally want to pull some information in. So ring buffer duration 30 seconds. We read in the right pointer, the 3 bytes. We access it there. And this is the write now. So this is the output that we disabled and deleted the code for. And then yeah, once it's finished writing, it does this advanced read pointer to read count times outstream bytes per frame. We just want to begin a frame. We want to begin a read there for that many frames, which can always be... Let's just try and completely gut this, in fact. Because if we are going to use it, I'm pretty sure we can. We're not going to need a buffer. We're not going to pass in any of this lot for now. We can always refer back to the example when we get there. So let's just try and clean this up. I'm going to commit to it and say we'll make this work. Microphone latency. Yeah, ignore that. So backend, if backend equals null, which it does for now, it's going to equal that. Otherwise, it'll be some value. So let's leave that. We will always connect. And is that all we use backend for as well? Nope, connect backend. But for now, let's clean this up. Don't care about that. API flush events. Microphone latency, I don't think we care about. Don't care about any of that lot. In device, if it's null, which is what it will be, get the default device. Otherwise, do all this crap that we don't care about. Clean that up. If it is null, which it is, we don't want that. Login output. Cannot probe, don't care about that. Output device, we're not doing. That can all go. Sort device channels, we're not using that. Layout is for output device, we're not using that. Sample rate, is that an output device sample rate at the minute? So that's just checking if the sample rates are compatible. Format, so you can see you basically just do this: input device supports format, supports sample rates, and you pass in a sample rate from the list. So we don't really care about that for now. I don't think it gets used here. The input stream, oh yes it does. So let's go back on that I'm in, and where does format get created? There. We don't care about the output device then. The input device we do care about. The layout, okay, let's undo a little bit of that. I think I excessively deleted stuff. Wonder if we have to specify that, because we're going to have to leave an output device in just to select a layout. Just really need an in and an output. Device 1, device 2. Can we just pass in the same device for now? Because we don't care about outputs. Sample rate, we don't care about the output. So all we're trying to do here is just let the input for now select all defaults, is what I presume is going on. And then microphone latency was, we'll go back to this. just 0.2. So we can just specify that, and I think that's just the delay in the buffer, 0.2 seconds. Now we get to the callback, we can open the stream. The output we don't care about whatsoever. Capacity, we're going to have to specify that. var micro latency is 0.2 seconds. We can now get the capacity of effectively the sample rate, the bytes per frame, and the latency times 2. So it's just how much we're going to get. That capacity is going in a buffer, which again we don't actually care about anyway, so all that can go. Fill count we don't care about. We're not making a buffer there at all. Starting that stream, waiting for events, disposing of that, and there we go. So that's all cleaned up to what you can now see quite easily. You just get a default device, set the default layout, sample rate, and format, create an input stream, set the callback here, which is where we then read, open the stream and start the stream, and then just wait for events. I presume then we can get rid of this. We can certainly get rid of all of the write, which is all that. Get rid of the buffer. We don't need to advance bytes, so all that can go. Underflow callback isn't used. So we're literally down to a single callback when we get the stream here. And free count, bytes per frame, we don't care about that. Don't care about that either. Don't care about that. Don't care about that. So frames left is write frames, which is, I think that's just infinite, you know. I think we just read it and carry on. In stream, because we're using a buffer there, which we don't use. So we'll make free count whatever we like, and then write frames we'll make max, which is we get passed in. So frame count max. So really write frames is just frame count max. Frames left is the same thing. So and frame count min, I don't think we use. So then frame count is equal to frames left. Or write frames used anywhere else? No, so we can get rid of that. And frames left is literally the maximum frames. Clean this up a little bit as we go. I guess that can also be that. Doesn't even need to be a variable here. Frame count. So we begin to read by the max frame count we can read. If the count is 0, we break, so there's nothing to read. Otherwise, if it's empty, due to an overflow, there's a hole, fill the read buffer. So we don't care about filling the read buffer with anything here. That's just nothingness. So this can change to simply if it's not empty in the areas, get the channels, read the channel count bytes per sample for each channel, get the area, copy the data, and this is where we are reading the data from the stream. Frames left minus equals frame count. Frame count's always max, so that'll never happen. So we're down to as simple as this. For each time we get a callback we want to read, and we just now need to copy the memory buffer back in here. So to do that's fairly easy. We just do a var bytes, do like, red bytes equals new byte array of the copy size. And then in order to extract from an unsafe area, we'll use fixed, and we'll do a byte pointer. Call it destination. This is like the unsafe code. We'll link to the safe code of read bytes. And like a using statement, we'll wrap this inside the buffer memory copy, which is unsafe. Get rid of this unsafe call here and just pass in destination. So that should now extract from memory copy into read bytes, and we should get to here. and see something. So let's see if we see anything there. And invalid value. Oh, we left connect backend in. That was for if the sound IO wasn't default. Let's try that again. Unable to open device. Okay, so something must be wrong with these. Format looks fine. Sample rate fine. That fine. Layout I'm not so sure of. We passed in the same in and output channel for layout. That was like a potential hack. So let's just get rid of that and maybe not specify layout. I'm not even sure what that is at this stage. There we go. Now do we have some data? 4 bytes. And it looks like we have 4 bytes of data. This will be the other channel, left and right, because we've got 2 channels. And I presume if I keep speaking, this would be different. Yes, that's clearly changing data. Don't know what the data is. It's clearly raw audio. 0 and 1 are never set. Maybe I've got to make a loud noise for that to kind of set. But we can always research, obviously, further when we know. So this is running, so let's just uncheck that. And now we get invalid value. On the begin read again, which is here. Oh, that's probably why we've left a for loop in here for the buffer. So this is good for every callback. We've already read the max count straight away. So we've read everything on the read. We're going to read everything, and then it's just going to loop forever. So we probably just need to delete this for loop out of here. And let's see if that now runs. And I guess the only way we'll know is... oh, that's no longer needed. Frame count. That can now be returned if there's nothing to read. There we go. We get reads. And now it's consistently reading. That's now got past that delay. And is that it? Is that all I needed to check? I think that's it. We're reading audio. So let's just... this will probably be a real mess. But we need to show something. So let's just do console.writeLine. Or in fact, if we just do console.write and then console.set cursor position 0, 0, so it just keeps resetting. And then we can write, I don't know, volume. Let's just literally output something so it shows something. And we'll just do kind of a sum of those bytes, I guess. I presume they're in some kind of order. And they must be changing, obviously. So let's do read bytes. In fact, let's just dump them all out so we can see all the numbers for now. I think comma 5. We'll give it a fixed space of 5 between them. So we can see, without it bouncing around, see easier those numbers changing. And there we go. So we can see the values. Yeah, so I've got no idea what those values are, whether they're working or not, or if we maybe need to record them, but they don't necessarily seem to just be volume related. So if I stay quiet, you see they don't go to 0. So it's not as simple as just, you know, a byte. We're going to have to figure out what this data is and do something with it. But I think there we clearly have audio running and capturing, and it's not that difficult to wrap this now in our code. There doesn't seem to be that many options to do it. This isn't exactly the prettiest, but it's working for mine, it's capturing, and all we've really had to do is a tiny bit of code here to start, and then a callback here, which you can even embed into directly into that part. We can clean this up even further. So it's a really small amount of code in order to capture audio, and we've just got to then reconstruct this, or these bytes basically. Instead of just doing 4 bytes here, we could stream this out better, and I think that's all we'll need. So I'm semi-comfortable proceeding with this then, this libsound IO. If you guys want to do the same test and see if it works on your mics, and let me know, and I'll test on Windows and Linux as well. If it works across the board for more people, we'll move forward with this and start integrating this into reading the audio data and processing it visually. So that's it for this one, guys, and I'll catch you in the next.